And we'd like to have quite of an interactive session. So please share your experiences either in the chat, either by raising your hand whenever you like. Also, if you have questions, we are more than happy to answer your questions. So this is the agenda for today's session. So the session will be roughly divided into two main parts. The first one will be more of an introduction, led by Maria Luisa from Urbesa. She will explain what is the bioeconomy, why we should focus on the bioeconomy, why is it an opportunity for local authorities, and then she will explain what is a biorefinery. It will explain the different types of biorefineries that exist. And then we'll move to our project, Circular Biocarbon, explaining what is the concept that we are developing. And this will be done by Yolanda from Socamex. So first we look at the feedstocks that will be used for this biorefinery, the final products that will be produced, and so on. And the final presentation will focus on the barriers that may arise during the development or the implementation of such a biorefinery, and we'll look at the different way to overcome those barriers. And so we'd like, as I said, to have more of an interactive session. So we'll try after each of the presentation to have some time for questions and answers, and also to start a short discussion. So for this, we'll have questions to the audience, and that would be that would be fantastic if you could share your experiences, ask questions around biorefineries, but also more largely about around the bioeconomy or biowaste valorization. So before I give the floor to the first speaker, Maria Luisa, a few words on the City Interest Group. So this webinar series is part of one of the many project activities, which is the City Interest Group. So the City Interest Group is basically a group of cities, of local authorities, so not necessarily cities. We've got different levels. They could also be municipal waste management companies. And the idea is that altogether, those organizations, those cities will have access to a series of activities within the project to learn on biorefineries, to share knowledge, to share experiences, but also to build capacity with the view on one day maybe setting up one biorefinery in their cities, in their towns, and so on. So this activities is coordinated by ICLE, so we are a city network, so that's why we are in charge of it, and supervised by Socamex. Really briefly, being part of the city interest groups give access to different activities, as I said, which are field visits. We'll go to different sites of the project, webinars. So this is the first webinar of this webinar series, workshops to really build capacities, to develop tools on how to set up a biorefinery, to city match exchanges, so networking events between local authorities and different types of stakeholders, and so on. And so all of those activities will take place during the duration of the project. So that's a really brief introduction, but we've got more information on the website. So I will share the link in the chat. And also, if you'd like to, if you're interested in knowing more about the City Interest Group, especially if you're a municipality, municipal waste management companies, feel free to write an email to myself, and I will be more than happy to give you more explanation and see if you could join. So without further ado, I'd like to give the floor to the first speaker, to Maria Luisa. Are you ready, Maria Luisa?
Yes.
Great. So I'm trying to unshare my screen. Good. So the floor is yours.
Thank you, Simon. Can you see my screen? Can you
Yes.
see my screen? Yes.
Yes,
Okay.
absolutely.
Yes.
Sorry, I
Thank
was
you, Simon.
muted.
Thank you. Okay, so hello to everyone. My name is Maria Luisa, and I'm going to present you the introduction part of the City Interest Group webinar. Number one, setting up, which is titled as Setting Up an Organic Urban Waste-Based Biorefinery, the Key Requirements. Well, as I said, my name is Maria Luisa. I am an environmental scientist with a PhD in environmental engineering. I have 6 years of experience as researcher in the biochar field, focusing on treatment of organic waste through various thermochemical processes for its possible valorization. And now I'm working in Urbaser since 2021 as researcher and development project manager with an active participation in this project, the circular biocarbon. Well, the table of contents that has been divided in three parts. Firstly, I'm going to introduce you on the biorefinery concept, as Simon said. Then I will continue with the sector about the valorizing biowaste with biorefineries. And finally, I will introduce you to the future circular biocarbon biorefinery. Well, the introduction of the bioeconomy. What is bioeconomy? The bioeconomy is an emerging and rapidly growing sector that will play a key role in the sustainable production of renewable biological resources from both land and aquatic environment. This is an essential development in the global drive for sustainability and is a key element in addressing the world's environmental challenges. But what is the sustainability? The sustainability is defined as meeting the needs of the present generation without compromising the ability of the future generations to meet their needs. So with growing demands on resources, ensuring a viable sustainability strategy is increasingly important. So the bioeconomy is a key component of this. The European economy strategy, in 2012, in order to stimulate the European bioeconomy, the European Commission launched its first bioeconomy strategy, an action plan with a stated objective to pave the way to a more innovative, resource-efficient and competitive society that reconciles food security with the sustainable use of renewable resources for industrial purposes, while ensuring the environmental protection. This strategy, adopted by the European Parliament, set out five overreaching goals to help establish a viable bioeconomy in Europe. One is ensuring food and nutrition security, then managing natural resources sustainability, reducing dependence on non-renewable unsustainable resources, limiting the impact of and adapting to climate change, and strengthening European competitiveness and creating jobs. Well, this is European, according to this European bioeconomy strategy, the European Commission said that the European bioeconomy is worth an estimated 2.4 trillion euros and comprises the production and use of renewable biomass from land and sea, and the use of waste to make the value-added products such as food, feed, bio-based products, and bioenergy. Um, it supposes an increase on 25% in the less than 10 years. On the other hand, European bio-based industries continued expanding, generating a total turnover of 750 million euros, which comprises bio-based chemicals and plastic, pharmaceuticals, paper and paper products, forest-based industries, textiles, biofuels, and bioenergy, and it supposed an increase of 23% in less than 10 years. According to the Connection National Bioeconomy efforts, at an European level, efforts are strongly geared towards creating interconnections between member states' bioeconomy strategies, which are now in place in all the countries. However, the nature of the bio-based activity varies considerably between the member states. For example, in Eastern European countries, including Poland, Romania, and Bulgaria, perform better in lower value-added sector of the bio-based economy, which generate higher levels of employment. Meanwhile, countries such as Belgium, Finland, France, and Sweden have the highest added value activities, as measured by the difference between turnover and employment. Mm, According to the opportunities of bioeconomy, there is a need to accelerate the phasing out the use of virgin fossil feedstock and it has become a top priority. Availability of the renewable carbon and innovation in technologies to convert that into products will be vital. So in this context, according to the Organization of Economic Cooperation and Development, biotechnology and biomaterials and ecosystem services are two opportunities to boost the bioeconomy. By 2030, for example, the biotechnology could contribute up to 2.7% of gross domestic product in industrialized countries and even more in developing countries, according to a new report from the Organization of Economic Cooperation and Development. For comparison, now the biotechnology currently contributes less than 1% to the gross domestic product. In the case of biomaterials and ecosystem services, will gain significantly, strengthening European competitiveness, creating employment and enhancing the health of ecosystems. Biomass for construction materials, fiber, food, and feed, furniture, and textiles is expected to grow, specifically innovative biomaterials. However, this report warns that the government and industry must break down the barriers which are represently holding back the further development and commercialization of biotechnologies. Such barriers cited by this report include technological challenges, regulatory issues, lack of investment, social acceptance issues, and market structures. According to this report, a fresh perspective is needed to foster resilience and smooth the transition to a circular post-COVID economy, with the framework of the European Green Deal and the European Recovery Plan in line with the European Bioeconomy Strategy objectives. Also, these experts highlight how unleashing the potential of the analysis drivers and trends towards the desired transformation of the bioeconomy requires appropriate policy integration. With the European Green Deal, the important steps of integration are underway regarding key European policies, especially biodiversity, circularity, climate change, food systems, forest protection and restoration, and also renewable energy. The bioeconomy needs to be part of all this integration. Well, now about the valorizing biowaste with biorefineries, currently, the European Bioeconomy Strategy aims to accelerate the deployment of a sustainable European bioeconomy so as to maximize its contribution towards the 2030. Biorefineries and bio-based products are vital in reducing global emissions and decarbonizing our energy systems because, as it is written there, biorefineries consist on the sustainable processing of biomass into a spectrum of marketable products such as food, feed, materials, chemicals, and energy, fuels, power, heat, using a wide variety of conversion technologies in an integrated manner. Nowadays, a total of 2,362 facilities, included biorefineries, are estimated in Europe by the European Commission. All of these facilities that you can see in the figure can produce, for example, bio-based products, like bio-based chemicals and material products, bio-based chemicals, including platform chemicals, solvents, polymers, coatings, plasticiers, agrochemicals, among others. Liquid biofuel, including bioethanol, biodiesel, bio-based jet fuel. Another type of products can be bio-based composite and fibers, including wood plastic composite, natural fibers, composites, and different type of fabrics. And other type of energy from biomass, including electricity, heat, and usually gas. Among them, only 296 are biorefineries, which are destined to produce bio-based chemicals and materials, as you can see in this figure. But going more in depth, only 3 biorefineries that produce bio-based chemicals and material uses other organic wastes as feedstock, different to agricultural and forestry wastes, such, for example, municipal solid waste. So It is clear that organic fraction municipal solid waste and sewage slot is not high exploded compared to other feedstocks like primary biomass from agriculture or aquatic biomass, forestry, or grasses. The current bio-based chemicals and materials supply from European biorefineries is estimated at 4.6 million tons. It is estimated that supply from new or expanded biorefineries could grow by an additional 3.1 million tons in Europe in 2030 in the high growth scenario. It is in a total of 7.7 million tons. Whilst in the low growth scenario, this could be limited to an additional 1.1 million tons. It is said 5.7 million tons in total, obviously estimated in the lower scenario. According to the current developments, we can see that the most important general drivers of bio-based chemicals and material supplies from European biorefineries we can find the European Green Deal, the governmental support for exploration and scale-up of biorefineries, the functional benefits that bio-based products are potentially able to provide, and the need to reduce dependence on fossil raw materials and products as well as their related greenhouse gas emissions. Among the advantages of biorefineries to waste management and specifically for cities and industries, we can find, in general, for example, biorefineries will collaborate in the implementation of the European Green Deal. The European also they can collaborate in the European Union bioeconomy strategy and with the new circular economy action plan for Europe. Also, biorefineries can obtain products that outperform their fossil counterparts, for example, by the biodegradability of some polymers. According to the benefits for cities, we can see that biorefineries offer citizens an alternative integrated management of liquid plus solid wastes produced by civil activities. Also, the biorefineries will generate wealth and employment through technologies that respect the environment. Also, they will promote good practices to citizens. According to the benefits for industries, we can find that they are a marketing opportunity for fertilizers manufacturers because industries will be able to phase out the use of peat, for example, by using these bio-based materials in growing media. Also, they guarantee changes in decision making for new models and management policies because they will support the transition of several sectors such as industry, agricultural, transport from fossil fuels to fossil-free consumption to zero carbon emissions. Finally, biorefineries can lead new links among cities and different sectors, as I said before, industry, agriculture, and transport. On the other hand, some limitations can be found to the organic urban waste-based biorefineries, such as waste composition and variability. Why? Because organic urban waste can be highly heterogeneous, containing a wide range of material with varying composition and quality. This can make it challenging to develop consistent and efficient conversion processes in biorefineries. The variability in waste composition may require frequent adjustments and optimization of the biorefinery operations. According to another limitation can be the waste collection and logistic, because effective waste collection systems are essential for the reliable supply of feedstock to biorefineries. However, establishing efficient waste collection infrastructure in urban areas can be complex and costly. Challenges may include issues related to the waste segregation, contamination, collection frequency, and transportation logistics. Another limitation can be the contaminants and impurities present in the wastes. Organic urban waste can contain contaminants such as heavy metals, chemicals, and non-biodegradable materials. These contaminants can pose challenges during the conversion processes, affecting the efficiency of biorefinery operations, product quality, and potentially creating environmental risk. Additional pretreatment steps may be required to remove or mitigate these effects of contaminants. Another limitation is the scale and economic viability. Why? Because the scale of operation and the availability of cost-effective technologies play crucial roles in determining the profitability of biorefinery projects. Smaller scale biorefineries may struggle to achieve economies of scale, while larger scale facilities may face higher capital investment requirements and operational complexities. Another limitation is the regulatory and policy framework. The deployment of biorefinery involves compliance with various regulatory and policy frameworks related to the waste management, environmental impact assessment, and product certification. This regulation can vary across regions and may require additional permits and approvals, increasing the complexity and cost of establishing biorefineries. Another limitation is the public acceptance and perception. Concerns related to odor, noise, traffic, and potential health and environmental impacts may arise from local communities. Effective communication, community engagement, and addressing these concerns are essential for the successful deployment of biorefineries. Another one is the energy and resource integration. Biorefineries require significant energy inputs for various processes such as waste pretreatment, conversion, and product purification. However, the integration of different processes and the traditional energy and resource flows can be complex. I think, yep. And finally, for biorefineries of this kind that produce bio-based products, currently there is a lack of evidence on the full life cycle sustainability benefits of bio-based products. Quantitative information on sustainability is needed over the full biomass to produce life cycle, including their end of life fate, to demonstrate their potential environmental and other advantages. So addressing all of these limitations requires a multidisciplinary approach involving technological advancement, policy supports, and effective stakeholder collaboration. Overcoming these challenges can help unlock the full potential of organic waste-based biorefineries and contribute to sustainable waste management and resource recovery. In this context, circular biocarbon appears. Circular biocarbon is a flagship type project in which the first biorefinery will be designed, built, and validated on an industrial scale for the recovery of the organic fraction of urban solid waste and sewage sludge into high-value final products. It's a 5-year European project that started in June 2021 and is titled Turning Carbon of Complex Organic Urban Waste Streams into Value-Added Products. Our funding entity is the European Commission through the Bio-Based Industry Joint Undertaking, BBIGU. This transitional collaborative project is coordinated by Urbacer, in which 11 partners from 5 European countries participate. But, well, in any case, please let me show you our promotional video in which I am pretty sure everything will be explaining very well. Beware.
I think there is no sound, Marissa.
No?
No.
No? Okay. Let me try again. Okay.
We did some sound checks before and it worked well, so it's quite
Yeah.
unfortunate. Yeah, it works.
In Europe, cities generate around 90 million tons of bio-waste every year. More than half of that still ends up in mixed waste that is landfilled or incinerated. In the European Union alone, greenhouse gas emissions from landfill sites are responsible for around 3% of total emissions. Now imagine if the organic waste generated in a city could actually be turned into new resources and end products. That's what the Circular Biocarbon Project aims to do. by changing the perception of waste as a problem to waste as a resource. We're working towards transition in Europe from a linear to a circular economy. Circular BIOCARBON is a first-of-a-kind flagship biorefinery designed to valorize the organic fraction of municipal solid waste and sewage sludge generated in a city into value-added products. Through a pool of cascading technologies, the biorefinery will produce 8 types of products for industries and consumers: coating of direct consumer products, coating of mechanical moving parts, coating of plastic molding tools, biodegradable and compostable waste bags, green graphene-based devices and products, biodegradable in-soil mulch films, solid organomineral fertilizer with biostimulant property, and liquid bio-based biostimulant. The biorefinery is a unique and integrated model to be built in 2 locations: Zaragoza in Spain and Sesto San Giovanni in Italy. The new approach aims to demonstrate a large-scale treatment of up to 100% of biowaste in a city. It will also open up the market for new products and business frameworks based on a circular vision of waste treatment. Circular carbon represents a milestone for Europe due to the implementation at industrial level and the replication potential in other cities. At the end of the project, commercial-scale biorefinery will be in full operation. The consortium involves 11 partners from 5 European countries, bringing together urban waste and waste managers, technological partners, and industrial partners. The 5-year project, coordinated by Urbacer, has an overall budget of almost 23 million euros, with a European contribution of 15 million euros through the Bio-Based Industries Joint Undertaking, BBI-EU. Keep track of our innovations and see our progress for yourselves. Follow us on Twitter, YouTube, and LinkedIn. Subscribe to our newsletter for updates, or visit our website for the latest news, views, and project information. Follow Circular BioCarbon today for a sustainable, innovative, and competitive transition to a bio-based economy.
Thanks a lot, Marissa, for this great presentation and for the video. I think it's quite
You're
compelling.
welcome. Before ending my presentation, I think it's important to highlight something that apart from the promotional video, because as I said, one of the main limitations mentioned before to organic urban waste-based biorefineries in the deployment is also applied to the bio-based economy, according to the European Commission. In the European biorefinery outlook to 2030 is indicated the following. Currently, there is a lack of evidence on the full life cycle sustainability benefits of bio-based products. Quantitative information on sustainability is needed over the full biomass to produce life cycle, including their end of life fate, to demonstrate their potential environmental and other advantages. So, circular biocarbon will develop also an impact assessment of the biorefinery, contributing on a quantitative information on sustainability over the full biomass to produce life cycle in the project. So, well, this is all. Thank you very much for your attention. Well, Simon, I don't know if I'm not sure if there are any question or comment, but if not, I would like to launch some question, as you said before, to the audience with the aim of opening.
I may have a question for
discussion.
you before. I mean, it's more of an open question. Also, maybe it would be interesting to see what the audience think. But so you mentioned at the beginning, when you introduced the topic of biorefineries, that biochemicals and bio-based materials, they represent a huge potential. That this potential is even growing from year to year. And on the other hand, you mentioned as one of the key barriers to the setup of biorefineries, the fact that waste collection systems, and especially bio-waste collection systems, were quite costly, difficult to implement, and that quality was hard to achieve. So do you think that by setting up biorefineries, cities maybe could be able to, by producing bio-based materials, bio-based chemicals, city will be able to some extent to fund some of those bio-waste collection scheme?
I think we need time and a good environment for a good development of the biorefinery. But I think if we have the good scenario, good legal framework, we have governmental support. I think biorefineries can develop very well because now the biotechnologies and other technologies are advancing so much. So yeah, I think so. But also, as I said, we need support. This is the most important thing, and a good environment.
All right, thank you. Do we have questions from the audience, either on bioeconomy, either on biorefineries, or more specifically on the project? So then we'll really deep dive on the biorefinery that's developed within the project. But if you have any general question, let's say, or any experience you'd like to share, feel free to bring it up.
Mhm. So I can share
Yeah.
yeah, okay. Thank you, Stefan. So this is some questions that I would like to launch to the audience in order to make a discussion board. As you can see, I divided the questions into sections. One related to the question of the bioeconomy, another one questions on biorefineries. According to the questions of the bioeconomy, I launched the question firstly, what about the bioeconomy in your region? How important is the bioeconomy in local, regional, political agenda? And how, do you have a bioeconomy strategy in place? And if so, which are the challenges that you are facing with regards to the bioeconomy? And for the section of the biorefineries, we have two questions. One of them is how is organic fraction municipal solid waste is treated at this moment and sewage sludge? And are there any biorefineries located in your city or region? And if so, do you know which type of biorefinery are they or any plan on sending up one? So uh, just please, I would like to hear you in just answer the question you with the question you see you feel more comfortable or you want to answer. So I will leave it them here just to see them, and yeah, it will be a pleasure to hear you. Thank you.
Thanks, Marisa. Yeah, we've got a few minutes. So circular biocarbon focuses on the organic fraction of municipal solid waste and sewage sludge, but we know that in some other cities, some other regions, you've got other feedstocks. Could be interesting also to hear about like your strategy, the perspective on bioeconomy in your region. We know that in Gipuzkoa, for instance, who is one of the attendees, there is quite a focus on the bioeconomy, that you get different feedstocks. Maybe it could be great to hear about what you'd like to do out of those feedstock. Yeah.
Well, okay. For example, Mikkeli.
Great. Yeah, thanks.
But well, the bioeconomy sector is quite big if we counting forestry and such. But for example, we have a biogas plant or biogas plants, 2 plants with altogether 5 reactors, and now 3 reactors are in use. 2 reactors use separately collected bio-waste from households and restaurants, shops, and 1 reactor use sewage sludge. And we use the biogas for vehicle fuel, and then we produce soil products and organic fertilizers. So, and it's big part in the Mikkeli city strategy. And we've been doing this for the biogas plant has been operating for 5 years, and our new wastewater treatment plant, which is part of the circular economy system, has been operating now for 2 years. So we have good modern new infrastructure in working.
Great. Thanks a lot for your testimony, Panu. So for the audience, Mikkeli is a city in Finland in the South Savo region, and Mikkeli is part of the city interest group. So if anyone else would like to share any testimony experience on bio-waste valorization, the bioeconomy, or on biorefineries, feel free to share it with us. And otherwise, we'll move to the next part of this session.
Well, in general, if I can add, the economy part is really the challenging, how to operate these plants economically feasible way. So it's quite a challenge, but we are coping.
So do you mean that the value that you extract from valorizing those different feedstock doesn't really cover the operating cost and investment costs of those facilities?
Well, yes. Well, we cover the costs, but it's a constant challenge, and but it's on sustainable track now. But the investment costs has been high, and the payback times are long. So it takes a lot of faith and effort to keep going on this track.
Great. So it's great to see that there are some pioneers like you who are showing the way forward. I guess it's a good way then to share best practices. Thanks, Panu, for your testimony. So I suggest we move to the next part of this webinar. So we will really focus on the biorefinery that is developed within circular biocarbon. So Yolanda, the floor is yours.
Okay, thank you, Simon. I will share my screen. Please let me know if you are able to see it. Are you able to see my screen? Okay.
Yes.
Okay, thank you. Okay, so good morning to all the attendees. In this new talk, we will be addressing some aspects to take into account when one is trying to design or to establish a biorefinery from the feedstocks to the final products. As an example, we will use the project Circular Biocarbon because our experience with the process of design of the biorefinery in this project has provided lessons learned, which could help other organizations in similar processes. I would like to very briefly introduce myself. Many of you already know me. My name is Yolanda Ballesteros, and I am a project manager in Socamex, as you already know, one of the organizations participating in Circular Biocarbon. I am a PhD in zoology, but in the last almost 6 years, I have been focused in wastewater and in general in the management of projects regarding the complete water cycle. In this presentation, we are going to talk about the process for setting out a biorefinery through the consideration of the general figures affecting biorefineries, the rationale, the explanation of the cascading approach, the requirements, and the role of local authorities. Finally, we will have some time for discussion. Okay, waste has, as my colleague Marisa has remarked, waste has high potential as feedstock for the production of high quality building blocks, materials, and products. It is produced in high quantities all over the world, providing ample opportunity for opening new markets. The consortium of circular biocarbon, as well as for sure other organizations in Europe, already have noted this. And this observation motivated the writing and submission of projects like circular biocarbon. When the first stone for this project was placed, the most recent Eurostat data for that moment indicating 1,300 million tons of urban solid waste produced annually and 91 kilograms per capita of organic waste coming from wastewater treatment. Those amounts have increased through the years a little. And in the same way, different studies highlight the great potential of biorefineries. The study we have in the slide, which is an American study, remarks that the global biorefinery market is expected to reach $210.3 billion United States dollars by 2027 at a compound annual growth rate of 8.2, with clients being members of the biofuel, animal feed, material and chemical sectors, and then users belonging to the fields of automotive, food and beverage, electricity generation, chemicals, and agriculture. All of it, together with the high rate of depletion of fossil fuels, make the biorefinery a choice which is more than acceptable. Wait. Okay, now. Okay. So still taking into account the data that I have just mentioned, as reported by different sources, for example, the study of the IEA Bioenergy Global Biorefineries Status Report 2022, or even the dashboard of the Joint Research Center about biorefineries, the number of biorefineries is still low. According to the Joint Research Center dashboard, for example, such a number is 296, which is an amount already mentioned by my colleague Marisa, for all the European Union. This suggests that biorefineries have a potential which is underexploited, and the potential is particularly underexploited for those biorefineries which use waste at feedstock, whose number in the European Union is of only 30. Europe and the world need to be less dependent on traditional feedstocks and materials, and hence demonstration of the feasibility of the biorefinery concept needs to be done. In the following slides of this presentation, we aim to review the steps followed in order to implement a biorefinery based on our own experience with circular biocarbon. We think this can help other organizations to know where to start and which steps to follow for the establishment of the model. A lot of things need to be taken into account when targeting the establishment of a biorefinery. Some questions need to be asked and thought carefully. Derived from our previous experience in circular biocarbon, and in this point, I would like to remember that the specific type of biorefinery we are addressing is the one using waste as feedstock. It is important to give response at least to the following questions. First of all, the feedstock. What initial feedstock can we count on? Are we able to obtain organic fraction of municipal solid waste? Are we able to obtain sewage sludge? Are we able to obtain both? And then, which properties does our feedstock have? This one is also important because these properties may be indicating how good our feedstock is for the purpose we have in mind, or they can be also indicating if we are complying with the law or not, of if the technologies which are already in place are suitable for the new feedstock which is going to be treated. Then another question we need to reply to is what legal documents do we need to respect? And also, what do we want to obtain from the biorefinery? Do we want to obtain building blocks that enter in another process for their final treatment? Do we want to obtain materials? Do we want to obtain end products? This is greatly related also with the market, with the demand of products in different places, with the local and regional needs, with the profitability of the selected product, or with many other issues. Now we are going to see in detail each of these questions through the following slides. The first question to reply, which I mentioned, was related to the feedstock. What initial feedstock can we count on? It is necessary to know beforehand the type of feedstock, as depending on it, the different processes and technologies of the biorefinery will be designed or adapted. Different steps could be necessary if we are going to treat only one of them, or on the contrary, we are going to treat both. All of it needs to be considered. Things that may seem obvious have to be also carefully planned. This may happen, for example, with the space for storing the feedstock, which may seem obvious but also needs to be planned. And also how much feedstock will we be able to obtain? Will this amount be enough for feeding the biorefinery? Will we need to collect in different points in order to reach a critical mass? And if that is the case, will a biorefinery be worth it here? In the previous slide, we also mentioned that the properties of the feedstock needed to be addressed. Knowing the properties of our feedstock is very important because these properties, as I have said before, may be indicating how good our feedstock is, if it is okay for the purpose we have in mind, if we are already complying with the law, or we need to apply some further technology or treatment in order to comply with the law. And if the technologies which are already in place in the current facility are suitable for treating that feedstock or that chemicals, or alternatively, we need to tune such technologies or implement new ones. In addition, according to the report of the European Commission on the situation of the strategy for bioeconomy, which appears on the slide, the cascading approach must be in the core of biomass utilization. In order to explain this point, we must first take a look at the meaning of cascading processes. Cascading processes are mentioned in recent publications dealing with circular economy. And for example, this publication of Campbell Johnston et al. Defines cascading as the sequential use of resources for different purposes, usually through multiple material reuse phases before energy extraction or recovery operation. In the process, resource circulation is promoted and contributes to higher natural resource efficiency over the entire material life cycle for resource extraction, product consumption to disposal. As we can see in the right part of the slide, in circular biocarbon, the building blocks and materials resulting from the previous step are in fact the input to the following step of the chain, and this is why it is said to be organized in a cascading configuration. In a biorefinery like the circular biocarbon one, where the feedstocks are treated in cascade, it is extremely important to adjust the characteristics of the machinery, the technologies, or even the interferences and processes so that they are able to deliver an output which is suitable as input for the following process. Moreover, it is important to make sure that the end products going out of the biorefinery comply with the desirable characteristics in terms of the market which is demanding them, or in terms of legality. This is why, in addition to the information we can obtain about the composition, for example, for the waste or from the wastewater managers, we need to make sure of the properties associated to the feedstock to be used. So in this case, relevant characterizations of the chemicals, building blocks, or materials involved in the process need to be done. In the case of circular biocarbon, complete batteries of analysis have been done for a whole year, involving physical and chemical, microbiological analysis, and also emerging pollutants. The tracking of the evolution of the values of such parameters through the cascading processes provides relevant information in order to design the different steps, technologies, and procedures to be implemented in our biorefinery. Another very important question that I have mentioned before is, what legal documents do we need to respect? This is of crucial importance if we want our biorefinery to be functional If either the refinery or the products generated inside of it are outside of the law, the model will hardly be successful. So this is another action leading us to the definition of the technical requirements of our biorefinery. According to the characteristics and the values of the different parameters in the matrices analyzed, the design and modifications of the different technologies need to be done. But in a parallel way, the legal framework and the desirable standards to comply with need to be also addressed in order to help define the technical requirements. Biorefineries can potentially produce a wide variety of products, so the legal framework to investigate can be really extensive. This is a hard job to do, which needs to be done in collaboration with the experts in its product. As an example, in the case of circular biocarbon, different building blocks, materials, and then products are targeted. You can see them in the list on this slide. But note that owing to confidentiality issues, these have been clustered and not referred to jointly for the whole group of products, materials, or building blocks. For each of these clusters, as well as for the initial feedstock from which they are originated, the technical requirements have been defined based on the biorefinery necessities, the legal environment, and other guidelines. This one is really an in-depth exercise which aims to cover all the variables that may interfere in the operation of the biorefinery, and it requires extensive time to think and try not to leave anything to chance. In the case of circular biocarbon, we worked or we gathered the necessary information through a questionnaire which contained more than 20 questions related to the categories we have from A to F on the slide, which are the identification of the building block, material, final product, and the technology employed to obtain it, the definition of the technical requirements based on the desirable characteristics of the input and output streams, a summary of the technical requirements of that part of the biorefinery, the suitability of the current framework for the establishment of biorefineries, the future perspectives related with regulations, standards, politics, or recommendations, and also other national documents of reference that have an influence on the establishment of a biorefinery. So here you can see the detailed information we requested in the questionnaire. Of course, we are not going to go through the complete questionnaire because it would be very boring. But for example, as you can see, the category A is only for the identification of the building block. And in category B, for example, information regarding the technical requirements from the biorefinery is assessed in the sense of what are the characteristics of the input we have to a technology, the desirable characteristics of the output from that technology, which is in turn related to the necessary input for the next technology of the cascading process. Also within that category B, the cards go deep in what are the legal documents to which the partners have looked in order to come up with the final design of a given technology. Then we have category C, where a summary of the technical requirements is requested. This is important as all the information assessed must be somehow reduced in order to use it and in order for the rest of the consortium to understand it. Normally, each of the partners counts on expertise about very specific fields, which are sometimes very hard to understand by another partner working with substances which are radically different, even though they are inside of the same biorefinery. Then, under category D, the questionnaire asks to please evaluate, in the view of the legal documents and standards reviewed, if the legal framework enables the establishment of a biorefinery, identifying barriers in case the framework is not good for it. This is the starting point where specific barriers are evaluated, accompanied by a wish list for the optimal solutions we would like to happen in the future as a facilitator of the uptake of the biorefinery model by the market and by the society. And based on this point, we will have another talk later where we will focus on those barriers specifically. Also importantly, the future needs to be taken into account. We start from the idea that the biorefinery model is not fully accepted yet by the market and by the population. A change in the legal framework is necessary in order to make the transition easier, and all of it will happen in the future. So the environment that will be happening by then is not the current one. It could be similar, could be a little different or much different, but in any case, not only the present framework, environment or conditions need to be considered, but also the future ones in order to guarantee success and compliance with what is next. And finally, in category F, other national documents of reference are evaluated. Particular conclusions derived from the analysis of the information gathered through the questionnaire I have just explained are out of the scope of this webinar, but as an example, I will tell you that for the case of the feedstock, we have 7 European documents affecting this input, this feedstock, related to, for example, hazardous waste, animal byproducts not intended for human consumption, protection of the soil, geological storage of carbon dioxide, pollutant release and transfer, environmental liability, or fertilizing products. Also, the feedstock are affected by 3 national documents dealing with contaminated soils, fertilizing products, and use of sludge for agriculture. The most of European regulations, as displayed in the graphic, the most of European regulations studied seem to affect the feedstock, and the most of the national ones to the biomass products with agronomic interest. But this is only an example. We are not going to go deep in all the results because we will need a lot more time. But I would like to remark that the information displayed in the previous slide, together with the complete information, has been used in order to prepare deliverable D1.1, which is the report on the definition of technical requirements, barriers, and solutions. This one is a public deliverable, which can be accessed through Cordis here. And I strongly suggest you to take a look at the deliverable, as it contains interesting information which can be useful as a starting point when targeting the establishment of a biorefinery. Okay, with all of this information combined with that coming from the characterization of all the materials and building blocks which were available through the cascading processes, we felt we had enough information as to design a successful biorefinery. In any case, close monitoring of the biorefinery operation once it has been built will be necessary in order to adjust or tune the technologies designed, that way coming up with the final design of the biorefinery. In the case of circular biocarbon, the targeted building blocks, materials, and end products have been defined on the basis of strategic frameworks observed, which is a key requirement for the model. Just to mention a couple of them, the opportunity of the precursors of biopolymers is the spatial situation of the biorefinery, contiguous to other actors of the value chain, as well as the availability of industrial partners able to approach them to the market. For example, for the case of the P-based resources with agronomic value coming from waste, the greatest opportunity is the slow release at a lower price when compared with traditional products of the same technology. And the strategic opportunity for the biogas-derived high-quality materials is to enable a transition away from petrochemical sources of carbon to a circular source. Selling products with as low as possible carbon emission will have a clear competitive advantage, as it will lead to emission reductions for the customers buying the product, for example. And also because currently no one is supplying the biogas-derived high-quality materials with a circular carbon source. So these are like the opportunities we have detected, and hence we have directed our biorefinery to the production of those specific products. And here we have a slide in order to ask ourselves about the possible role of the local authorities in the transition to a biorefinery model. Things we can think of are, for example, that local authorities can be informed of the new possibilities. For example, through participation in research and development projects, for example, like circular biocarbon. Some of you are already participating here, for example, through the CITE interest group or through the advisory board. You can also be up to date with trends and politics in Europe dealing with circular economy. Also, if the local authority carries out the facility management themselves, then it is important to identify opportunities for the establishment of biorefineries. Do we have enough feedstock? Do we have potential clients, meaning clients that, for example, consume products traditionally produced and that could potentially change to bio-based ones? Are the relevant stakeholders willing to change to bio-based products? Is the general public willing to accept the new products? Is the industry willing to accept the new products made out of bio-based materials? Then, if the management of the waste treatment facilities is carried out by a subcontractor, the local authorities may have a role in making easier the path to achieving the biorefinery model. For example, by awarding necessary permits, by trying the red tape not to be a big burden, by facilitating dialogues among the different components of the value chain. Other thing in which the local authorities may have a role is in establishing mechanisms that make easier the transition. For example, reduce local taxes, provide additional pieces of land for the new facilities, promote locally models for sustainable production and consumption, or others. Local authorities can also try to attract private investment or target the preparation of legal documents or municipal circular economy plans, or participate in the preparation of regional plans. What I mean is that, for example, in the Spanish city of Granada, a municipal plan for circular economy, in this case, especially targeted at building sector, has been approved. And also in the case of the Spanish region of Asturias, a participation process was open for citizens in order to define the measures of the circular economy strategy in the region. All of them are ways enabling the involvement of the municipalities in the achievement of a circular economy. Okay, and in this point, as this one is the last slide of this talk, it's a good moment to ask the attendees why what they think, for example, the role of the local authorities can be or should be, or to what extent or in which sense they think the local authorities should be involved in the advance toward the biorefinery model. Another thing I would like to listen to about your opinion is how aware are local stakeholders of opportunities offered by biorefineries, or more largely by biowaste valorization, or what measures are there in place to raise awareness in the same way as happened in the previous presentation by Marisa. I would like to listen to your thoughts about these questions to the extent you feel comfortable replying to them. So
Thank you, Yolanda. Really compelling presentations. Also a good opportunity for people to ask questions.
Yes.
If they like. Maybe I can start this process so that it's easier for people then to ask other questions. Yeah, my first question will be that you mentioned the characterization of the two feedstock, including the biowaste, which will be used to produce bio-based materials and chemicals. And so we all know that biowaste, this is something that varies a lot according to seasons. It's marked by a high seasonality. It also varies over the years. So this characterization, is it something that you are going to do only once, or regularly to make sure that the feedstock that is being used to feed the biorefineries stay the same?
Yeah, I think it should be done, from time to time, or of course, responding to well-established and well-thought and well-written plan for the analysis, sampling and analysis. But yes, we have done a first characterization before the starting of the operation in order to adapt the technologies or to design the technologies. But of course, once the biorefinery is operating, it will need to be monitored. Different parameters will need to be analyzed on different samples. In order to because also we need to update the design of the biorefinery. It was predicted within the project. We have the initial design, but that design will be improved after the operation. So all of those characterizations done during the biorefinery operation will serve to do that, to improve and to come up with the final design of the biorefinery operation. In any case, we have taken care to be or to do a design for the biorefinery as much flexible as possible, meaning that it can work with different feedstocks. I think this is also important because you are in a real environment. It is not likely that you have always the same feedstock available. No, it could vary from time to time. So we think it is important to have a flexible biorefinery able to work with different types of feedstocks.
Great. Thank you for this response.
You're welcome.
I see that we've got a question from the audience, from you, George. So if you'd like to open up your mic and share your questions, ask your questions with to Yolanda.
Yes. Good morning.
Good morning.
Thank you. Thank you, Maria. Thank you, Yolanda, for the presentations, and thank you, the moderator Simon. Where I come from, we are typically an agricultural state, whereby I see a lot of organic waste, and 90% of it is put in landfills mainly, and I don't see any biorefineries or maybe any plans to set up any refineries around. So my question is, are the biorefinery processes and technologies the same with sewage sludge, plastic molecules, and also other organic waste? Are the processes the same and technologies and technological requirements the same? Thank you.
I'm not sure I understood you properly, but what I think you are asking me or Marisa is if the technologies would be similar or not.
Sure.
Okay. No. In order to design a good biorefinery, which is able to to meet your requirements, you need to ask yourself which is your feedstock. What are the properties of the feedstock you start from, and what you want to obtain once you have processed all that feedstock. It could happen that the technologies are the same, but it could happen that they are radically different. Where you can recycle from this presentation is the general process to do it. The steps to follow for the assessment of the initial requirements of your biorefinery. But in relation with the technologies, I wouldn't say they will be the same. They could be the same or they could be completely different.
Great. Thank you, Yolanda. Thanks, George, for your question. So you mentioned that we are living in a quite agricultural state. What is the state you're referring to while you're living? Interesting to know.
I'm coming from Uganda.
Okay, wow.
Mhm.
So we've got a global footprint. Thanks a lot for joining and for attending. We hope that this is useful for you. Yeah. Do we have any other questions from the audience?
I really would like to know what present local authorities or the attendees in general think that local authorities or what they think the role of the local authorities could be, because I have proposed some roles for them, but I don't know if they agree, if they feel new items should be added, or they feel they wouldn't be responsible or or a role to play in any of them. What do you think about the role of local authorities? I can go back to the slide.
So maybe to start with, local authorities are in charge of collecting waste. I think that's crucial for biorefineries. Also often in charge of wastewater treatment plants, directly or not. Also crucial if you would like to collect sewage sludge. I guess there is also a big role around educating, raising awareness towards residents, but also towards businesses, local businesses, maybe to kind of open new opportunities. Is that correct?
Okay, thank you. Yeah. Interesting.
Joanna?
Sorry, you couldn't see the video. Hello, Johanna from Mikkeli again, Finland. In City Loops, in the project I'm working in, as we have worked with the local authorities, being also kind of a base client. So it's to do with the procurement of the municipality. As Panu said, we have the biofuel production for the cars. So the municipality, they are promoting the use of biofuels in the local buses and waste trucks and such, and also smaller cars that they use in normal municipality work in different cases. So I think the base customer idea is quite a good one that we got from the City Loops and all the procurement workshops they held and procurement guidelines that they've done for this.
Oh, that's really interesting. Thanks for your contribution, Johanna. Yeah, nice initiative.
Get another hand that is raised. Oui, or is it a legacy hand? But yeah, in any case, thanks to Joanna for highlighting the role of public procurement. Great. If we don't have any other questions, I would suggest to move to the last presentation. We are slightly behind schedule, but that should be fine.
Okay. I don't know if you can already see my screen.
Not yet.
Okay. Okay, now you should see it. Okay, perfect. So let's start with the last presentation of the webinar. In this presentation, we are going to focus on the barriers that the organizations might find out while trying to establish a biorefinery, guided by the experience acquired during the execution of the project Circular Biocarbon. In case someone has just joined the workshop, I would like to very briefly introduce myself again. My name is Yolanda Ballesteros, and I am a project manager in SOCAMEX. I hold a PhD in zoology, but I have been working in the management of research and development projects related with water during the last 6 years. In this presentation, we are going to talk about the barriers we have detected during the first stages of the project in what has to do with the biorefinery planning and implementation. For each of the general barriers detected, a solution is provided, as we will see during the presentation. Other points to be addressed are how the barriers merge with the design of the biorefinery and the next steps to take, and also the key points to be remembered once the webinar is over. And finally, we will have some space for discussion. Okay, as explained in the previous presentation, a questionnaire may help to gather the information which is necessary in order to carry out the optimal design of a biorefinery, so that it is profitable and useful in the present and in the future. This was the case of circular biocarbon, where the starting information needed was written in a questionnaire, which has already been explained in the previous talk. This questionnaire, if you remember, gathers each one of the aspects that have been considered relevant for the design and implementation of the biorefinery. Out of the parts A to F we have explained in the previous presentation, one of them contained questions about the barriers identified, especially in relation to those barriers of policy or institutional nature. It was the group of questions included within D, which addresses the suitability of the current framework for the establishment of biorefineries. The questions were replied for the different building blocks, materials, and end products, as well as for the biorefinery concept as a whole and for the feedstocks. As I have said in the other presentation, during this presentation, you will note that the different building blocks, materials, and then products have been clustered in general categories, appearing in the current slide, in order to protect the confidential information of the project. Okay, under group of questions D, the cards asked the partners if they considered that the legal framework was a facilitator for the establishment of a biorefinery, or if, on the contrary, barriers had been detected in relation to the establishment of the biorefinery, to specific technologies and/or building blocks or materials or final products. Anticipating the work to be done in the framework of the project as well as after the project's end, potential solutions to the barriers identified were drafted as well, aiming at, on one hand, trying to adapt to the legal framework as a mechanism to guarantee success of the biorefinery model in the market, and on the other hand, if that was not possible, to give solutions to reduce the impact of the legal framework into the biorefinery model. A third aim was to concretize the wish list for the change in the legal environment, enabling the future preparation of a policy paper which includes desirable changes in law. This policy paper is a deliverable to be prepared by the end of the project. So after collecting all the info requested under that group of questions, D, here you have a table with all the barriers identified. In the following slides, you will see the list of the main barriers which were identified together with the proposed desirable solution. Our questionnaire focused on barriers, as I have said, related to the legal or the regulatory environment, and some of the most relevant of these barriers have to do with the lack of a clear legislative framework, as is the case of the building blocks which are precursors of biopolymers, or the case of the end products coming from those biopolymers. In those cases, the solution which was proposed for the barrier was to push towards the adoption of a comprehensive legislative framework fully coherent with the EU circular economy and bioeconomy strategies. Other barriers identify the banning of certain feedstocks as inputs for the biorefinery, providing a reasonable solution based on the evaluation of a real danger for consumers as a way to decide whether or not to forbid them. And lack of a clear legislative framework or non-awareness of the legislative framework have been identified also for materials derived from biogas and for the nitrogen-based products with agronomic interest, and hence the proposed solution has to do with the definition and provision of clear regulatory frameworks. On the whole, 12 barriers and solutions have been identified for circular biocarbon, most of them regarding the building blocks which are precursors of biopolymers, as well as the end products coming from the biopolymers. Yet the barrier regarding the organic matrix with agronomic value coming from wastewater and municipal waste is very relevant, as well as it affects the feedstock. As we will see later, the view of the consortium in relation to all of it will be considered for inclusion in the policy paper to be delivered by the end of the project. As you have seen, barriers have been only very briefly commented here, but you have all the information in the deliverable that has been prepared by the Circular Biocarbon Consortium, which is public and available in Cordis. I have referred to this deliverable in my previous presentation. Deliverable 1.1, the report on the definition of technical requirements, barriers, and solutions. And I strongly advise to download it and take a look at it for more complete information. Okay, interestingly, okay, let's see. Okay, interestingly, other studies on biorefineries have identified legal or policy-related barriers as important for the uptake by the market. In those cases, it was the restrictions imposed by the policies or law in place, together with the lack of specific frameworks that were considered to hinder the uptake of the biorefinery model. For example, only to mention a couple of the barriers related to policy or regulations referred to in the Outlook to 2030. The revised Renewable Energy Directive provides incentives for bioenergy and biofuels and hence for the use of feedstock for that purpose. So this is suggested to create a scenario where the biomass supply is dedicated for energy purposes, not for the production of other materials. Also, in relation to the Waste Framework Directive, a barrier for the use of waste in biorefineries may be the non-uniform classification of materials as waste, residue, or co-product. Feedstocks seem to be classified differently in different countries, so that a feedstock can be seen as a co-product in one country, as a residue in another one, and this ambiguity in the classification can give as a result that a material has to comply with both product and waste legislations. Or, for example, the European regulation on registration, evaluation, authorization, and restrictions of chemicals, as all of you probably know, aims to protect human health and the environment by identifying the properties of chemical substances. Under this regulation, registration of the innovative chemicals produced in a biorefinery is required, with more expensive prices when the product will be placed in the market in higher quantities. And this is difficult to pay, for example, for companies which are starting in the market right now. Or, for example, the Common Agricultural Policy, which, as all of you know, aims to ensure affordable food in Europe, while at the same time protects farmers' income and the environment. So in relation to this policy, costs of the feedstock produced in Europe are generally high compared to other regions. So bio-based products produced in Europe may be at a disadvantage owing to the greater cost of the feedstock. Only to mention some of the barriers detected in this further study. The example of the biorefinery outlook, this document, which is on the screen, gives us a wider framework with information not only related to waste-based biorefineries, but still it is useful to the purpose of this talk. According to the same study, other types of barriers, not necessarily related to policy or legal environment, must be taken into account. And even though in the first study carried out within circular biocarbon, we have focused on the policy-related ones, in the future, other types of barriers will be added to the study. For example, those barriers related to the business. For example, biorefinery products are substituting fossil products which are already in an established market, which means barriers due to the already established businesses which already have optimized value chains, and also we have detected a trend to resist to change. This is also a barrier to do the shift to the bio-based products. Also, consumers may be less willing to pay green premiums, or sometimes bio-based products are associated with a lower quality by the general public. All of them are barriers that need to be somehow addressed. Other
Excuse me,
barriers.
Yolanda.
Sorry.
We
Yes.
still have 3 minutes left.
Oh, okay.
Yeah.
So, yeah,
Yeah,
I will
maybe.
only. Yeah.
Yeah, I
Sorry.
conclude, or maybe just mention the part on local authorities, because I guess
Yeah.
that would be quite
Okay.
interesting for participants. Thank you.
Okay, perfect. No problem. So, yeah, here you can see there are other kind of barriers related to economy, to the life cycle analysis, which Marisa has also mentioned in her presentation. And okay, Simon, did you? No, you were referring to this one, maybe. Let's go directly to this one.
Just a short conclusion, so that we've got maybe 1 minute for people to ask 1 or 2 questions.
Yeah. Okay. So. Okay, derived from the study in circular biocarbon, as well as from other sources, what seems clear is that barriers exist in relation to the design, planning, or implementation of the biorefineries. In the case of circular biocarbon, those barriers, together with other types of information prepared in the last few months, have been the input for the biorefinery design. These other types of information used for the biorefinery design have been the results from the characterizations I have already also mentioned, the definition of the technical requirements based on the desirable characteristics of the input and output streams, the law of application, and the future perspectives related to the regulations. So with all those inputs, we have designed the biorefinery. And in any case, the monitoring of the biorefinery operation, once it has been built, will be necessary in order to adjust the different technologies and come up with the final design of the biorefinery. But other necessary step is the consideration of other types of barriers, not only policy related, which will be done later in the project. And in this slide, we can see a summary of the key takeaways to take with you once the webinar is over. So I will read them. The transition to a circular economy is necessary in order to guarantee resource availability for upcoming generations. Part of the current legal framework is outdated and needs to be reviewed in order to address the new challenges. Industries and society need to be made aware of the need for the change and of the safety of the bio-based products in order to improve willingness to use bio-based products. And communication, education, and marketing are crucial in order to achieve that. Creation of technical knowledge is of utmost importance in order to demonstrate feasibility and safety, and this will be the basis for changing the politics. And we also have the possibility to take actions at the local level mediated by the local authorities. For example, through local incentives, agents for facilitation, local plans for circular economy, or others. Okay, and now we reach the time for questions and answers and for the discussion. And as happened with my previous presentation, I have some questions for the attendees, and I will be also happy to reply to questions that the attendees may have to me.
Thanks, Yolanda. So we are a bit late.
Yeah,
so
I know.
maybe if we've got questions from the audience, maybe 1 or 2 questions on barriers related to setting up a biorefinery and how to overcome those barriers. Yeah, feel free to ask questions. All right. So I guess you'd like to move to your next meetings because we all have really busy calendars. In any case, thanks a lot to our 2 speakers, to Marisa and to Yolanda, for their really interesting presentations. Thanks to all the participants for being here with us today for this first webinar of the City Interest Group webinar series. So if any of you is interested in joining the group, just let us know. You can reach out by email. Yeah. And so we'll organize the next webinar in the fall. So the date needs to be set yet, but we'll communicate it to you in due time around the same channels than for this one. So thanks everyone, and I wish you a good afternoon.
Thank you. Bye.
Thank you.
Have a
Goodbye.
nice day.
Bye.
Bye bye.
Bye.
Thank you.